Escolteu, anem a començar l'última sessió d'avui, que parla sobre la valorització energètica eficient. Hi haurà un petit canvi. Intervindrà primer el senyor Bernd Morun, que ens parlarà de l'augment de l'eficiència energètica de plantes mitjançant l'ús de millors tecnologies FGC disponibles. Bernd, when you can. What you want. So, please.
Good afternoon.
Only 15 minutes.
Yeah, good afternoon, ladies and gentlemen. You've heard we must be quick. Sorry, but I hope it will be done. Good luck for the translators. So today I will speak about increase of power plant efficiency using best available technologies. I think everybody should know what it is, this best available technologies created by the European legislation. Something goes wrong. No. The table of contents will be clean gas values for municipal waste incineration plants and how to reach it. Criteria for BAT in the next point, best available technology and energy efficiency. Then at least a comparison of different FG of flue gas cleaning technologies and at least practical experience results in Germany with dry absorption plants. It means also changing wet scrubber technology to dry absorption and semi-wet scrubber, because in Germany now we make a step back to the future, I would say. After we create wet scrubber plants, a lot of wet scrubber plants, they go now back to simple systems because energy efficiency is better. Okay, at first here you see the clean gas values for the relevant components. This means HCl, sulfur dioxide, HF, and so on, in daily average value and also in possible half-hourly average values. This you must reach and fulfill if you want to fulfill the law for clean gas. If you look for a waste incineration plant, you are typically run between 1,000 milligrams raw gas HCl and 4,000 in peaks, and sulfur dioxide normally for municipal waste 300 milligrams sulfur dioxide up to 2,000 in peaks. It could be also a half-hourly peak. This means you need an absorption rate from over 99% HCl and also over 90% sulfur dioxide, at least also if you have peaks over 99.8 and 98% sulfur dioxide capture. For this, to reach this, you have you have at least 3 principal steps to clean the gas. It means the wet flue gas cleaning system, the semi-wet scrubber system, and the conditioned dry system. The next slide shows a wet scrubber system. This is a built one in Cologne, in Köln, in Germany. And you see everything which can be done, had been done here. This means spray dryer to dry the wastewater coming from the scrubber system, fabric filter, scrubber system 1, scrubber system 2. Then you need a van because you have a big difference pressure about this. Afterwards, you have a heat exchanger to put a little bit from the waste gas heat back to this gas in front of catalysts. A gas burner, natural gas burner to get the temperature for the catalysts, and the catalysts after all fixed bed coke reactor, and then the second van, the ID van, to blow out the gas in the environmental. Here you see a man standing there. You see what happens with this kind of systems. It's difficult to run and expensive, really expensive and big. The next one is a simple system, a more simple system. It's a semi-dry system or semi-wet system. It's at least the same. Here you make from calcium oxide a milk of lime, water mixture, blow it in a spray absorption, and afterwards you have still a filter to capture the dust and the salts and put it to the residue and go over a stack. You can blow up a little bit the system by blowing in additional additive and activated carbon to capture dioxins and mercury. But at least, it's written underwards here, underlined, each of cubic meter water which you put in for wet scrubber systems and also for semi-wet scrubber system leads to a loss of 800 kilowatts of heat energy in gas for evaporating the water. The next one is a conditioned dry system with lime. This means here we have the emission source, water, blow in powdered lime in the reactor, make a recirculation lot. Sometimes it's a high dust recirculation. It means with 60,000 cubic meter gas, you need 60 tons per hour recirculation. I call it not a cleaning system, I call it a transport system for lime. But also here you have this loss of water by conditioning by water. The newest system now, at least, is with a new additive, this bicarbonate, sodium bicarbonate system. It's a totally dry system with a high efficiency additive. How to go back? No. So, okay, here. You blow it in directly in a temperature range between 140 and 220 degrees. It reacts really fast and completely. You blow in the activated carbon for dioxins and mercury, have a fabric filter and a VII. After all, a heat exchanger to put out all this heat of the flue gas and can use it. Since the last years in Germany, nobody wants to build wet scrubber again, so the 50% of the new built systems are still this special dry, simple dry system and use the heat of the gas absolutely afterwards. So coming down to this BAT criteria, you must look what does it mean BAT criteria, what you must look for. You must look for the best available technology, for the absorption rate you need, for the system availability, it's really important for the people who run the plant, for the behavior of the at pollutant peaks, investment costs, it should be not so much, regulation action, it means can you fulfill the regulation, additive supply cost, residue disposal cost for deposit afterwards, and the operating costs, it means energy, personnel, and maintenance. If you make a comparison between these three principal kinds of cleaning, wet scrubber, spray absorption, this is spray absorption and additional dry absorption, a conditioned dry with lime and conditional dry, total dry with bicar, you will find here the typical absorption rates which could be obtained if you use these systems. HCl, 99%, 98%, you see it's every time the same. The big difference you will find in sulfur dioxide capturing. This means 90% wet scrubber and then it goes down, but here with bicarbonate still higher as a wet scrubber system. In the last line you see the stoichiometric ratio you need. You see the wet scrubber still run with stoichiometric ratio 1.1. The other one still much higher, but the total dry with sodium bicarbonate is still also near to the wet scrubber system. About heavy metals and dioxides I don't want to discuss because it's really common to catch it easily, really easily by blowing in activated carbon powder. Here you can see it after all, I think, in the sampling from this conferences, criteria for the several peaks of BAT criteria and the if it is good or not good. At least you will find out normally you should take a wet scrubber system or total dry. In the next slide you see the absorption rates and the stoichiometric ratio and absorption rate which are possible if you use different additives in a dry system or a semi-dry system. For you see here for sodium bicarbonate, it's still running well up to nearly 100% absorption rate with stoichiometric ratio 1. For calcium hydroxide, for HCl is still also okay because you must know sodium bicarbonate is much more expensive as lime. So if we found a case where we only capture HCl, we use still also lime. But the big difference is here in the capturing of sulfur dioxide. You see three different limes. This is a very expensive special hydrated lime. And you see that the curves much more worse as bicarbonate.